Good afternoon, ladies and gentlemen. A warm welcome to our members, and thank you for joining us today for the CISA Practice Notes webinar. The practice note for today's webinar is Practice Note 101, Basic Implementation of BIM Systems for Members. My name is Oliver Rowe, and I'm the Contractual Affairs Manager at CISA, and I will be your facilitator for today's webinar. What are the CISA Practice Notes? In short, the CISA Practice Notes are a practical resource that helps consulting engineers in the South Africa operate efficiently, ethically, and in line with industry's best practice. They are designed to improve the overall quality and consistency of work within the profession and to protect both the engineer and their clients. To access the CISA Practice Notes, please visit our website at www.cisa.co.za. Under the Guidelines tab, you will find the Practice Notes. This is a service for our members, and as such, it can only be accessed by our member firms. If you are from a member firm and would like access to the Practice Notes, please contact Gillian, who will be happy to assist you. You can contact her at gillian@cisa.co.za, and I will place this email into the chat during the webinar. A bit about the history of the CISA Practice Notes. They began in 1962 as advisory notes, with a name change in 2012 to Practice Notes. Over the years, they have been updated and added to, where we now have over 100 such notes. The practice notes are categorized into 6 specific areas, which are client and appointments, construction stage services, good business practice, legal responsibility, and disputes, professional conduct and development, quality and risk management. If while you're reading these practice notes, you feel that they may need to be updated due to industry changes, please don't hesitate to email me at oliver@cisa.co.za, and I will have our professional team review the practice note. Some house rules before we introduce today's speaker. Please can I request that any questions be posted in the Q&A at the bottom of your screen, and any comments be placed in the chat. Now let me take this opportunity to welcome our guest speaker for today's webinar, Mike Aldous. Mike Aldous has over 30 years of experience in the built environment, holding an MSc in Built Environment Science, a BCom in Property, a professional civil engineering qualification, and an international postgraduate project management qualification. His extensive career spans more than 60 healthcare projects, from renovations to large-scale development, and includes involvement in landmark initiatives such as the first 6-star rated government building for the Department of Environmental Affairs, Soccer City, and the EXA award-winning Mauritius Multi-Sport Complex. He's a strong advocate for sustainability, green building, and climate resilience. Mike has worked with the Green Building Council of South Africa since its inception, contributing to the development of Green Star rating tools and serving as an assessor, faculty member, and technical advisor group participant. His passion for built information modeling, BIM, smart technology, and data-driven design has supported his focus on improving sustainability outcomes through digital delivery, advanced analytics, and AI. Drawing on his expertise in condition assessment and refurbishment, Mike continues to champion regenerative designs and the use of emerging technologies to reduce environmental and health impacts, optimize performance, and create a more sustainable built future. Without any further ado, I'm going to hand over to Mike to share with us on BIM. Mike, over to you.
Great. Thanks, Oliver. Thank you very much for inviting me, and thanks for hosting this session. I think it's an excellent platform that has been going for a very long time. So let's not waste any time. After that introduction, I think we've burnt half the time. You were supposed to praise it. Anyway, moving on. Let's get cracking on the core concepts and implementation of BIM in the consulting engineering practice. So this is largely built around the CISA PN101 practice note, and as Oliver has mentioned, I think it's imperative that this is a resource that CISA provide to members, and I know they sometimes go somewhat overlooked in the background, but they definitely are worth a read, and particularly for informing the way the industry is going. So let's get into the agenda. So just a quick overview of what we'll be looking at today. So understanding BIM and its industry context, the scope and objectives of BIM implementation, and then the BIM execution plan, BIM tools, technologies, and data exchange, value-added BIM services for clients and stakeholders, challenges and barriers, and then probably one of the most critical aspects, allocation and distribution of liability in BIM projects. This one we're going to spend a fair bit of time on. So a lot of what's covered in the practice note is a very good summary of BIM as a whole. So I'm not going to spend a huge amount of time repeating or dwelling on what is in the practice notes, but rather to try and unpack some of the critical components that have a direct impact on the consulting engineering practice. And this is scalable, whether it's a small practice or an extremely large practice. So let's move on then. I'm just going to turn my video off so you're not distracted by me looking up and down between different screens. So let's move on. So understanding BIM and its industry context. I think given the maturation curve of BIM to date, most people have heard of it. And I think given the relatively sort of technologically proactive South African consulting industry, is most people have some exposure to BIM in its current form, and it may just depend on what level that takes. So we'll go through some of the mandatory information. So from a BIM definition point of view, building information modeling is a process that begins with creating intelligent 3D design. I think the emphasis there is on intelligent 3D design. It's not just a way of turning your 2D CAD drawings into pretty 3D drawings. The real leverage comes from the intelligent 3D design aspect. So that 3D design model, and then uses that model to facilitate coordination, simulation, and visualization, as well as helping owners and service providers improve how buildings and infrastructure are planned, designed, built, and managed. So that pretty much wraps up BIM in a nutshell. From a purpose perspective, one can then look at it a little bit further and say BIM can alleviate many of the business challenges that architects, engineers, construction professionals, and owners face by providing greater project insight earlier in the design and construction process to help them make more informed decisions. On a project that takes advantage of BIM, information is coordinated and consistent, creating efficiencies throughout the project lifecycle. BIM also improves planning, cost forecasting, and project control, making it easier for teams to collaborate and communicate. So this is all very nice from a theoretical point of view, but in experience, I think probably one of the biggest advantages of BIM, particularly in the local context, is the ability to leverage and maximize visualization content. So being able to visualize projects makes it far, far easier to engage multiple stakeholders, particularly in a country where we have 11 official languages. We have a very broad degree of technical experience within different stakeholders, both in the public and private sector. And I think from engineers, it's all too common for us to sort of roll into a meeting with a wad of plans, roll them out on the desk, and give ourselves a pat on the back because nobody else understands them. But the real benefit of BIM in communication is being able to take that platform and leverage it to create visual interactive models that people can fully appreciate and understand the impact of proposed infrastructure, the nuances, the context, the spatial implications. All these key aspects and elements are benefits of BIM that aren't necessarily captured in the formal definitions. So moving on, we just look at the BIM workflow and life cycle. So we start off with the conceptual design, and I think this is where BIM started making some inroads. It was able to look at massing models, and very much in the architecture space. I think as built environment professionals, probably the largest contingent came out of the Autodesk Revit product, and that allowed for quick massing and far more visual analysis and assessment at an early stage in design. Moving on to the detailed design, and the analysis side of it, this is where the visualization aspect really shines, and being able to communicate those results, whether it's the potential efficacy of your solar panel arrays, or whether it's the thermal impact of your facade choices on your building, or the implication of concrete. And I think one of the growing aspects where we're seeing more and more focus now as well is what is the embodied carbon impact of the project. And this is where BIM has an incredibly important role to play, by being able to quantify and codify those CO2 emissions that are locked into the building from the outset. So we're seeing a lot more focus on embodied carbon now. It's becoming a feature of some of the international ratings tools. In fact, even the South African, the new version 2 of the Green Star tool that's due for launch imminently has a far greater focus on carbon emissions. And then moving on to the documentation side, again, being able to generate a fully comprehensive documentation from a BIM perspective. Looking at the fabrication side, I think this is probably one of the areas in South Africa where we don't particularly excel compared to international competitors and international markets like the US, Southeast Asia, and even the UK, where fabricators are far more integrated into the BIM design process, being able to take your design and then turn it straight into shop drawings for approval, and then turning that into actual fabrication, right down to creating CNC code for cutting and bending, shaping, etc. Then looking at the construction side of things, there again, benefits here are the potential to leverage not only the 3D from a visualization point of view, but the 4D and 5D from a time and cost perspective. Then construction logistics, if one looks at some of the showcase projects in the Middle East, particularly where you have incredibly large projects with hundreds and hundreds of different work packages simultaneously, the construction logistics and programming aspect makes a big difference. Operation and maintenance, again, this is an area where South Africa is not particularly advanced compared to other parts of the world, and I think there's a long way to go before we're at a point where we can actually leverage this to its full potential. But definitely worth bearing in mind, and worth staying abreast of current thinkings. And then we've obviously got the off ramp to demolition or to renovation, and the cycle starts again, leveraging that BIM information at each step of the process. So looking at it from an adoption, maturity, and industry challenges point of view, I think the BIM adoption and challenges perspective in South Africa is one that if you've ever tried to hire very experienced BIM staff in South Africa, you've experienced firsthand. But it's growing, but hampered by inconsistent maturity, a lack of skills, and absence of standards across the industry and within the various project disciplines. South Africa faces uneven BIM adoption, skills gaps, lack of standards, resistance to change in industry, compounded further by regional and technical knowledge differences across both the private and public sector from a client point of view. From a BIM framework perspective, an often missing element is a detailed BIM framework that guides implementation, including scope, roles, standards, execution plans, liability allocation, and these are all important aspects in terms of understanding BIM and your individual firm and service offering. So clear scope and roles. Again, given the varied maturity level across the industry in South Africa, what we see is that certain areas lack a clear scope and roles. So roles like BIM manager, coordinator is essential for success and an integral part of the BIM execution plan. So these are roles that haven't traditionally existed in the traditional consulting practice, but are becoming more and more fundamental to the delivery of projects as BIM becomes the sort of preferred execution methodology. And then we move on to interoperability and standards. So we've got software incompatibility, data loss, and highlight the need for robust standards. So here we look to ISO 19650. ISO 19650 is the basis for information management, and replaces the old British 1192 standard. And this essentially defines the improved protocols that allow for effective information interchange between parties within a project team or project environment. And in order to get this to work properly, it's critical that there's a diligent management and a proactive risk mitigation approach to implementing this. So then moving on, we're going to have a look at the scope and objectives from a BIM implementation point of view. And this is getting down more into the nuts and bolts of how do you actually get BIM into your business, and what is effective and relevant and fundamental to your core service offering. Because each entity has a somewhat different requirement, ranging from large multinational consultants through to small niche, very focused consulting firms. BIM covers the whole adoption, but comes in so many different flavors across that spectrum that it's very critical to make sure that we drill down and develop very much unique BIM solutions that actually are fit for purpose for our particular applications as consulting engineers. So just looking at the scope, roles, and responsibilities. So I think probably the most important thing here is BIM is not an IT project. So let me reiterate that BIM is not an IT project. Yes, the software might come from your IT department, but it is a fundamental shift in the way projects are delivered. So it's more about driving change and change management than actually just rolling out a new set of software and sending people off to a couple of training courses. So when one looks at the BIM adoption challenges, South Africa faces uneven BIM adoption, skills gaps, lack of standards, and resistance to change industry. We've touched on all this before, and compounded by further regional and technical knowledge. If one looks at the implementation in your organization, it really needs to be driven from a top-down approach where there's complete buy-in across the entire spectrum of the organization. So there needs to be a very clear BIM vision from a leadership point of view. Is why are we moving in this direction? That driven BIM leadership then needs to start looking at how to implement this and the resources and the change management protocols, etc., that are needed to actually drive this change. Then moving forward beyond that, we look at the gradual integrated change. And I think this is critical for, particularly in a South African context, where a lot of firms are sort of small to medium-sized firms, and effectively your day job is delivery. So these changes need to be gradual, integrated changes that need to be worked into existing delivery timeframes, etc. And this needs to be planned fairly carefully to make sure that you leverage the benefits of BIM, but do not compromise on your service delivery. And this is one of the areas where, in my experience, what we found is that working with your particular software reseller, whether it be Autodesk or MicroStation or Bentley or any of the other service providers in the BIM software space, is that they essentially have the insight, having seen multiple implementations across industries and businesses very likely similar to yours, and are a wealth of knowledge when it comes to avoiding some of the pitfalls and looking at mechanisms that are able to develop tools, skills assessments, gap analysis, etc., that are able to drive this process and to maximize the speed and quality of implementation. And I think also, given that most of these resellers are resellers for international software, there is a wealth of knowledge that's been drawn from BIM implementations globally over the last 10, 15 years that have been distilled into far more practical application modules that can be implemented and applied to business. So definitely reach out to your software supplier or reseller and discuss options and opportunities to collaborate on getting this process adopted within your organization. And again, just don't leave it to the IT guys, otherwise you're looking for problems down the line. So if we look at changing business as usual, the BIM leadership team must effectively ensure that the BIM vision is translated into actionable tactics to produce the desired outcomes and performance in line with the organization's strategic objectives. So that sounds like it's pretty much cut straight out of a business management textbook, but effectively that is what it is. You know, the role of leadership is to drive the change, and managing the change associated with BIM implementation as an initiative across the organization. So we look at bridging the gap, we look at the high profile communication, we then look at the training and education, we look at the contracts and legal considerations, and then compliance, auditing and quality control, and then measuring BIM maturity. And this is where, if one looks back at Practice Note 101, this is covered in a fairly good level of detail, and it provides a very useful framework for looking at each of these elements and developing an approach that is based on industry best practice as it currently stands. So then we drill further down into the actual nuts and bolts of BIM execution. So once you're into delivering your BIM project, probably one of the most fundamental pieces of planning and work in that is going to be the BIM execution plan and project workflow. So if we look at the purpose and structure of the BIM execution plan, this is essentially a document that pulls together and codifies all the relevant standards, protocols, information interchanges. So from a comprehensive BIM deliverable perspective, it includes drawings, reports, specifications, schedules, models defined by geometric, alphanumerical, and documentation components. And I think it's important just to step back and realize that a lot of people have this impression that BIM is actually pictures, drawings, etc., what you see on the screen and the fancy visualizations. But the reality is it's actually a database. Everything is defined and codified in the back end. In fact, Autodesk University at their international convention always have a competition where specialists have to basically build a BIM model only using the back end. So only using the database alphanumerical perspective without any access to a graphical interface. And it makes one realize that the power of the data behind the picture. So again, the defined roles and responsibilities, ISO 19650 gives a range of guidance in terms of standards. And there are also a number of documents drawn from organizations around the world. I mean, those that spring to mind are the Royal Institute of Chartered Surveyors, the Singapore Building Authority, the International BIM Forum. You know, each of these organizations has distilled years and years of experience across thousands and thousands of BIM projects and begun to draw out the common threads. And I've included some of these in the references at the end of the presentation, and I encourage you to actually look at them, particularly if you're just starting your BIM journey, to learn from some of these international experiences. So the BIM execution plan essentially outlines the workflows, the milestones, the tasks, the resources, and the risks, and is developed collaboratively with project leadership and stakeholders. I can't emphasize enough the stakeholder component, because what we find is, particularly in project teams, where there are different consulting services at potentially different levels of BIM maturity, it becomes far more critical to define a common ground in terms of who's delivering what and to what level of detail, etc., so that there's no issues further down the project delivery timeline. So ongoing scope and objective review. The BIM scope and objectives are clearly documented, communicated, and regularly reviewed during the project lifecycle. And again, that's critical. BIM heavily relies on proper quality management. Given the scale and complexity of the data, it's imperative that there are means and mechanisms in place, particularly from a risk management point of view, to make sure that what's going on in the actual model is aligned with what the actual design intent is from a construction point of view. We'll get to this in some of the case studies a little bit later, and we can see some of the implications of what happens when the wheels fall off in this regard. So if we start drilling down into the components of the BIM execution plan, it obviously includes the basic details, the project information, name, location, description, etc., and key stakeholders with their contact information. And then the BIM objectives and uses. So this is really where the clear definition of project-specific BIM goals and the intended uses of BIM throughout the project lifecycle are fully fleshed out and communicated transparently to all stakeholders. And this is really critical when it comes to how this information is going to be used once the project is handed over. So it looks at the design coordination, the clash detection, the quantity takeoff, but more importantly is what is this data actually going to be used for at the end of the day? Once that as-built information is handed over to the procuring authority or the client, what is going to happen to it? Is it going to be used in future? Is it going to sit in somebody's drawer on a flash drive? Is it going to sit in a cloud server somewhere? The real benefit comes down to facilities management actually fully embracing this BIM handover information and using that as part of their ongoing management and expansion or maintenance of the facility. So we've touched on roles and responsibilities again, just making sure that everyone knows exactly what their responsibilities are and where the lines of those responsibilities start and end. The BIM process and workflow, a detailed description of the BIM process, protocols for collaboration, and the specific data exchange formats and software platforms to be used. And while this might sound relatively simple, what typically tends to happen, though, again, is different entities within a project team have different preferences as far as tools go. And what we find more and more is that different year versions of software, 2023 is no longer compatible with certain features in 2025, or the 2026 software has some glitch. So it's critical that there's a standardization and everybody agrees on the data exchange format and the software platforms are going to be used. Okay, then onto information management. So standards for data, naming conventions, requirements for the common data environment. Again, this draws largely on the 19650 standard, which defines a large number of these elements and aspects. So we're not going to drill down into the nuts and bolts of that, but just to be aware that there are a very robust definition for each of these. Then we look at level of development, although this is often referred to as LOIN now going forward. And that looks at the specification for the required detail within the models and what's shared. From a quality control and assurance perspective, one looks at the procedures for quality control, the validation, and ensuring compliance with industry standards for BIM deliverables. This is a fundamental aspect of risk management in the project delivery. Then an identification of potential BIM-related risks and proposed mitigation strategies, delivery strategy. We look at project milestones, the schedule of deliverables, plans for regular updates and reviews, and then collaboration and communication. This again is one of the foundational aspects of BIM, is that it's really built around collaboration and communication. So to get the maximum out of the software and out of the process, one needs to make sure that there are very clear lines of communication and that the collaboration protocols are very, very well defined. We typically see challenges in this regard between structures and MEP services, for instance. Then if we move on to software and hardware, list of necessary BIM software and hardware along with compatibility considerations. Again, this goes to the type of tools in very much same that we discussed the software earlier. This goes through to the hardware and the protocols that are used for information interchange. If there's any particular cloud collaboration platform that's going to be used, or whether there's going to be hardware required for a local instance or server, as well as the security and proprietary information protection. We'll touch on this a bit further later on, but this is one of the growing challenges in a BIM environment is who actually owns what data and who's responsible for which aspects of this common data environment as it sits in a collaborative environment. Then we've got training and support. I think the reality is that given the pressures that most consultants are under in terms of delivery, there is going to be a need for training and support to be able to make sure that you optimize your BIM workflows in the shortest amount of time possible. And this can be a combination of external and internal resources. It always helps to have some experienced BIM resources within the project team that literally act as a sort of catalyst for enhanced training and support within the project team itself, rather than relying exclusively on external services. Then looking at the handover and post-construction, so guidelines for handover BIM data models. Again, this is something that needs to be very clearly agreed up front so that what is handed over actually meets the project requirements. So if we move on, so we touched on this, LOD or LOIN as it's more commonly referred to now. So what is your level of detail? I think one of the big challenges one sees with early BIM implementation is that there's this wow factor to the point that the software is capable of dealing with so much data to such a fine level of detail. So we can go right down to the nuts and bolts in the door lock or every component in a valve assembly. But this begs the question, is it relevant and is it applicable to what you're trying to do? I think this is where a lot of consulting practices lose a huge amount of time, is over modeling or over complicating the models relative to the purpose for which those models are based. So there is a level of detail or LOIN system that essentially defines what each level of detail is, or the level of information needed for a particular application. So we start with the most basic one, which is really the structural concrete system. And bearing in mind that BIM is not just a drawing, there's a degree of intelligence behind it in terms of the information built into the model. So a beam knows it's a beam based on its defining factors within the underlying database. So for a level of detail 200, and these are probably terms you'll come across on a regular basis, and probably more and more going forward in tenders and requests for proposals, etc., as more clients become familiar with what they actually want. So here we have the type of structural concrete system and the basic geometry. If one then looks at the level detail 300, it now has more detail around that particular structural element. We then start moving on to level 350, and now we're starting to see a whole host of other elements built into it. And as you can see, this very quickly starts to scale up in terms of the time taken to actually build this level of detail into your model, and also whether this level of detail actually adds any value to your model in terms of implementation. So, I mean, a lot of this is codified in other ways, whether it be SAN standards or various other things. But if you are going to be doing advanced 5D time and cost modeling, then the model needs to be appropriate to a level of detail that allows you to extricate the correct information to be able to drive that. So 350 is typically the most advanced that we tend to look at, and only for very specific applications. And I'm talking largely from a civil and structural background here. It does somewhat differ, particularly in the HVAC and wet services and electrical space. But if we then move on to level of detail 400, you can now see that this is a far more complex piece of modeling to be done, because it essentially fully references the element with a full set of supporting back-end documentation and database details. And then we look at LOD 500, and LOD 500 essentially is the as-built documentation that's handed over at the end of the project. And this can often take the form of different levels of detail, but is typically referred to as 500 as part of the handover documentation. So then moving on to BIM tools, technologies, and data exchange, we can see that there's a number of considerations here. We're looking at interoperability challenges. We've touched on this previously, so software incompatibility. There are a raft of different file formats available from hundreds of different vendors. And this makes data exchange particularly difficult, particularly when one loses fidelity. You know, it all looks great in your software, but when you export it out in some generic format to be able to be read by a different piece of software, all of a sudden things don't look quite as correct as they did initially. So software incompatibility is an ongoing challenge. And I think as each manufacturer tries to drive their own product, it's going to remain this way for quite some time. There are several initiatives globally trying to drive a more standardized data exchange format, but these are still works in progress at this stage. And then data loss. So data loss is something that has come up more and more, particularly from a security point of view. So the conversion process between different software file formats can lead to a loss of data. and that's critical around the parametric information. But one of the other aspects really is around the security of that data. You're now sitting with a model that multiple people have contributed to, that is potentially sitting in a cloud location or hosted somewhere else, and it's easily susceptible to malware, internal malfeasance. There are a range of risks that need to be considered as part of the security aspect of data loss. Um, Software version differences we've discussed again. The 2022 doesn't speak to the 2025 to be aware of. And then standardization and protocol challenges. So lack of industry-wide standards. I think this is going to be an ongoing situation, particularly given the largely bespoke nature and complexity of the built environment. It's probably somewhat different in the manufacturing environment, where or automotive or some of the other industries, where there are very, very clear guidelines, etc. But essentially, many construction projects, each project is a unique and bespoke iteration of a particular set of rules. So the lack of universal standardization across the industry does lead to confusion and some inefficient workflows when teams use different protocols. So this is something to be aware of in terms of setting out your BIM execution plan up front and making sure that you capture this. In a very similar way, non-standard data formats between vendors does make things a little bit more complicated. And then we look at the lack of standardized processes. So again, 19650 as a standard tries to remedy some of this in terms of the information interchange perspective, but it also is fairly generic in the sense that it doesn't deal with vendor-specific information and is largely agnostic in that regard. Then data and protocol challenges, data management and integration, parametric loss, inconsistent project protocols. These are all similar aspects to what we've discussed already, so I'm not going to spend a huge amount of time dwelling on those. If we look at the value-added BIM services for clients and stakeholders, this has always been one of the sort of selling points of BIM, and it's an area in South Africa that we haven't quite seen the level of maturity and uptake as we've seen in other countries that have far more robust BIM implementations as part of their national building regulations and standards, etc. For instance, several Middle East countries now have a fully digital plan submission process that is able to deal with the actual model being submitted around a large range of other supporting information as part of that submission process, as opposed to our somewhat more simplistic systems currently in place locally. So if we look at some of those some of those value-added services, I think probably the most useful one that people are aware of is cost estimation. Having built your model with the relevant information, a beam knows it's a beam, a floor knows it's a floor, so you can assign costs and quantities and extract that from the model, which is then able to provide a fairly detailed cost analysis. What it does do is it definitely speeds up the process of iterative design. So you can look at 20 or 30 different proposals and see which one makes for a more cost-effective solution. What we're seeing now as well is this cost estimation is not only looking at it from a financial cost, but also looking at it from a carbon cost point of view. So what does your building cost in terms of embedded carbon? There was a great documentary several years ago where it was titled, How Much Does Your Building Weigh, Mr. Foster? Pertaining to Norman Foster, the architect, and looking at how much embodied carbon is actually in a building. So how much does your building weigh from a carbon perspective? Then the next one that has seen fairly good uptake is the schedule analysis. So this integrates project scheduling with the model, and it's able to visualize construction sequencing and timelines, and it facilitates early identification of potential delays and bottlenecks, allowing proactive schedule management. It also enhances coordination between design and construction teams, improving overall project delivery. So to give you some idea of this in actual practice, what we've seen on several projects is that the doors are built before the air conditioning unit's installed, and then the air conditioning unit doesn't fit through the doors. or the beam is too long to be maneuvered up the staircase. So all these iterations can actually be visually interrogated from a modeling perspective as part of the clash detection and coordination. And it highlights the fact that you can't build the second floor before the pile caps are done. And it looks at that from a very visual perspective. You may not pick it up immediately in reams and reams of documentation, but when you see the second floor suspended by sky hooks with no supporting infrastructure below it, it's very clear that there's something wrong with the schedule. So this has been a very powerful tool from a BIM perspective. Clash detection. So automated clash detection identifies conflicts between different building systems, and everyone's favorite is the structural MEP. So the engineer wants a meter deep beam, the MEP consultant wants to put a 800 millimeter duct through the 1 meter deep beam, and this is generally where the early structural and MEP and even electrical to some extent coordination pays huge dividends from a project delivery perspective. So reducing cost of rework and change orders by resolving issues in the digital environment rather than having to stand on site with your pencil trying to sketch out a site instruction. It also improves collaboration among stakeholders by providing a shared platform for issue tracking and resolution. So given the digital tools available now, all clashes can be tracked, can be tagged, can be referred back to the responsible person in terms of resolution. And this is a powerful audit tool as well when things go wrong. Then facility management. So BIM model serves as a digital asset for ongoing facilities management and maintenance. Provides detailed information on building components, systems, and maintenance for schedules. Supports lifecycle management, enabling efficient operation, renovation, and future upgrades of facility. An important aspect of this as well is also just looking at with the growing pressure towards net zero and decarbonization, the facilities management aspect is actually becoming more and more critical, because the reality is, I mean, probably 90% of the buildings that are in place already have a design life of 50 years plus and will generally be extended beyond that. So a lot of the buildings that are in play at the moment are going to be around for a long time. And these aspects of BIM actually make it more and more viable to improve the operation, the environmental sustainability, etc., of these buildings. And I think with the incredibly rapid pace of AI, what we're going to see is BIM and AI merging in such a way that AI is actually able to take over some of these tasks to a large extent and actually run the iterations and the scenario planning and look at ways of actually making for a better built environment based on the amount of data. Because at the end of the day, BIM is all about data, that the data is in the back end. And with the power of AI now moving in that direction, the ability to crunch petabytes of data is becoming a more and more real situation within the built environment. It's no longer just confined to the sort of aerospace industry and some of the other more obscure tech-heavy entities. Okay, so if we look at challenges and barriers to BIM implementation, we've got the skills gap. So growing the rate of BIM adoption alignment with international practice has resulted in a skills shortage, particularly in South Africa. We've seen this from a recruitment point of view firsthand. Trying to find people with the right skills at the right level of skills is becoming more and more difficult because of the mobility of local staff. There's been a lot of them snapped up by international players in different markets. So it's critical that we build skills on an ongoing basis just to keep the industry fed with the relevant skills and to be able to promote this excuse me, as a delivery model. Roles and standards. Again, South Africa has a fairly limited level of standards when it comes to a local context. However, given that we can leverage international experience and expertise, we need to make the most of that. It's very much like the old cell phone. We managed to skip the 1G and 2G and jump straight into 3G and learn from other countries' mistakes, experience, and roll out a far more robust system. And BIM, I think, is exactly the same thing, where we have that opportunity to take the work that Singapore, the UK, or the US, much of the EU has done, and even the Middle East, and take the sort of the really cream of the crop, and use that as the baseline for our own BIM standards. Then BIM execution plans, we need to build strong policies around the BIM execution plan that aligns with project deliverables. Again, the BIM execution plan is not just a copy and paste document that gets rolled out in every project. It really needs to be customized to each project. Building a stadium is a very different exercise to building a small pump station. So it needs to be geared towards the work at hand. There's no point in spending hundreds of man hours on a BIM execution plan when the work's value is sort of R1 million. So it needs to be commensurate with the level of effort and the level of complexity of the project that is going to be implemented. So challenges in BIM adoption: change management. Nobody likes to have their world rattled, and I think the reality is that for most consulting firms, there's an ongoing delivery pressure. So it's about finding your finding your sort of synergies within this environment, and being able to adapt and make sure that the change happens, but that it doesn't directly impact your ability to deliver. Then we get on to the more interesting stuff, and I think this is really where sort of BIM is still in its infancy, because it really comes down to, I know many of the CISA practice notes provide excellent insight around risk management and mitigation strategies, etc. And there's a huge amount of value in those practice notes that, while not necessarily BIM focused, are just as equally applicable to the BIM environment. So the first one is the legal and contractual environment. So here it's imperative that clear roles, liability distribution, professional indemnity insurance risks for managing a BIM environment are very clearly defined. What we see, particularly in the South African context, is we get a lot of half-baked requests for proposals that don't really outline, somebody's heard of BIM, we want a bit of BIM in our project, but it hasn't really been defined as to what level of BIM, what the contractual arrangements are going to be. So at the end of the day, contractual agreements govern the liability distribution among BIM contributors. So at the end of the day, we've got architects, we've got QSs, we've got engineers, and these form the foundation of the engineering team, and also the fundamental elements in the dispute resolution process. So it's critical that you understand the risks of what you're committing to, and the interplay between the different partners and parameters in that contractual relationship. We've then got technical risks and infrastructure. So hardware and software play a critical role, and cloud-based computing continues to grow. So there's a connectivity risk, with more and more software now being cloud-based or requiring a internet connection. What happens if you lose your internet for a couple of days? Your business comes to a grinding halt. And we've got the security vulnerabilities, including cyber risk of, what happens if your entire common data environment is hit by ransomware? Whose responsibility is that? Who's liable for that? What insurances are in place, and how are they apportioned between the different members of that common data environment, given that it's been used by multiple parties at the same time? Policy and adoption challenges. So skills gap, changes in national standards. These are all areas that have a technical risk as well on the BIM journey. And then from a national BIM policy development point of view, so South Africa's BIM national policy is under development, aiming to standardize BIM adoption practices. And I encourage everyone to have your say and stay informed, and make sure that your voice is heard in terms of what we want to see from a local context. As much as there are great solutions internationally, these also need to be customized to the South African context and the way projects are delivered here. So if we look at legal risks in BIM and CD, these are some of the areas where things have gone wrong, and they're the court cases to prove it. And this is really where You need to have your sort of head screwed on and actually make sure you've read your contract, your tender document, and interrogated the scenarios of how this plays out. So BIM and CD enhanced collaboration, but introduced legal challenges around data ownership and access rights. So we'll see in a later case study how this plays out. And then common disputes typically involve design errors, intellectual property, and unclear contractual terms in project delivery. And then mitigating legal challenges is around proactive risk management and standardized protocols help to reduce legal conflicts and ensure smooth project execution. But here it's imperative that each party that is partaking in a common data environment or a BIM collaboration process to very clearly understand and annotate and capture in their contractual terms what their risks and liability are. So if we look at from the common causes of dispute, so ambiguous ownership. So everybody uploads their stuff into the cloud. Now we've got the architect, the quantity surveyor, we've got the electrical engineer, etc. And then it becomes a bit murky as to ownership of the BIM models and the conflict that this causes over usage rights and control between parties and access to proprietary information, etc. So you're essentially handing over a huge chunk of intellectual property into a common data environment to be shared for the benefit of the project. But at the same time, you also need to be able to cover yourself in terms of protecting the own rights to your intellectual property. So these are things that need to be defined up front. Access rights issues. So disputes arise when access rights to the common data environment are contested or restricted. We'll see this a little bit later. Then design errors and liability. So errors in BIM design can cause project delays and cost overruns, leading to liability claims. How is this apportioned and how is the responsibility determined? So as much as BIM provides collaboration, it can also transfer errors through the chain without the right checks and balances in place. Intellectual property concerns, as we've touched on, so unauthorized reuse of or modification of models raises intellectual property disputes among stakeholders. If one looks at the international legal data to date, we've had several instances where clients have taken the model from one project and tried to recycle it in its sort of largely its entirety into another model without making the necessary payments. And then the question becomes more complex in terms of risk and liability, etc., and protecting those intellectual property rights. Then communication and documentation. So poor communication and inconsistent documentation worsen misunderstandings and enhance legal risks. So if we look at the first case study that we've pulled out, this was probably one of the first and most seminal legal cases to be tested in the UK in 2017 between Trent Engineering and Mott MacDonald. So the dispute was over data access. So the core conflict involved blocked access to data after a business relationship breakdown. So Trent Engineering had failed to pay Mott MacDonald for various services. Mott MacDonald in turn turned off their access to the common data environment and basically locked them out of the system. Therefore, they were unable to deliver on their deliverables because they no longer had access to the data environment, and in turn incurred additional costs because they were not able to meet their contractual obligations. So the legal decision emphasizing contracts, the court ruled for clear contractual terms governing data access and intellectual property rights. And this case was one of those that really shone the light on how critical it is to be able to show in very clear contractual terms to sort of non-BIM aligned parties when standing in court as to what the clear contractual relationships and obligations were between parties. And then the importance for BIM projects was that the case highlighted the need for explicit agreements on data control and usage in BIM workflows. This is an area that's often overlooked. People are all too happy to collaborate until things go wrong, and that's when the wheels come off and it becomes a complex litigation. So another one, this is based on a US project. So the BIM model showed the correct layouts. So everything was correct in the BIM model. However, the 2D drawings that were issued to site to the contractor were incorrect and had not fully communicated the 3D models, which related to incorrect MEP installations. Obviously, the contractor had a substantial claim against the client for the supply of incorrect information by his appointed consultants. And here, the failure in communication among designer, client, and contractor led to critical coordination errors. So this goes back to my previous point around communication, is making sure that just because it's BIM doesn't mean it's right. It needs to be right in the model, but it also needs to be correct in the information issued to site. What we're seeing on some projects now is that the actual model gets issued to the contractor, and the contractor then develops their own effectively construction response to that. However, the more common delivery is still to hit the contractor up with a set of drawings derived from the BIM model rather than actually hand over the model itself. And this just goes on to reinforce the importance of a review process with a robust review and a clear communication protocol to ensure that costly mistakes are avoided. If we move on, so design errors and delay claims. The impact of design errors, so errors in BIM models can delay projects and increase costs, causing significant disruption. The legal claims and disputes, so delays from design often lead to legal claims focusing on responsibility and project coordination. At the end of the day, when it comes down to a dispute, there's always somebody to blame, and it's generally never the person doing the blaming. So it comes down to cover your butt as much as you can from a contractual point of view at the start of the project, rather than trying to deal with it when things go wrong. So the digital accountability shift. So the BIM use shifts slightly to digital accountability, emphasizing the importance of review and validation protocols. Again, to my point around, so BIM isn't always right. It still needs a very robust check and approve process built into that BIM execution plan to make sure that the deliverables in play are actually correct and fit for purpose. So mitigating the litigation risks goes back to clear workflows and validation methods and define contractual responsibilities to help reduce design-related legal claims. So if anything, I think these are the areas around BIM that are probably more murky and less well defined. You know, there's hundreds of documents defining the workflows and BIM execution plans, et cetera. But from a legal and accountability context, this is what consultants really need to be looking at from a practice perspective, and how to protect yourself, and whether you leverage feedback from your insurers or whether you're relying on information from legal advisors. Just be aware of the potential risks. So while it all looks rosy at the outset, it may not land up like that at the end of the day. So data ownership and intellectual property. So defining the data ownership, who actually owns the data and who can use that data for what. And this is important in terms of the obligations from a consulting point of view in the timelines that data must be kept for to meet the statutory requirements. So what happens at the end of the project? It was hosted on a cloud-based system, which is now shut down. No one has access to this data anymore. It may sit with only one party. And as was highlighted in the Transverses McDonald case, the potential issues around unpaid invoices causing denial of data access and licensing conflicts is a very real challenge. So defining the data ownership becomes a critical component. And the best practices for intellectual property are effectively required to be in context. I think this needs to be developed further legally. So the other aspect is BIM and construction defect litigation. So the reality is, if you BIMmed it, there's an audit trail. And what we've seen in a few international cases now is that BIM provides detailed digital records that aid courts in verifying construction compliance with approved plans and specifications. And it also either works for or against you in terms of early detection of construction issues through clash detection simulation, preventing disputes before they arise. So just make sure that whatever is in the BIM, you can defend and think of it in the sense of, would you put it on a billboard outside your house, very much like your Facebook posts, etc. It needs to be robust, and it needs to be fit for purpose, and it needs to be defendable and complete. Then that brings us to collaborative transparency. So collaborative BIM use fosters transparency and reduces misunderstanding of the project stakeholders, facilitating dispute resolution. However, one needs to make sure that the information going into the common data environment is correct. So lessons learned from a contractual practices point of view: defining roles and responsibilities is critical. Incorporating standards is one of the foundational aspects, and then addressing the legal aspects from a contractual and intellectual property and licensing and dispute resolution point of view. Even in South Africa, we haven't seen much from a professional indemnity perspective around BIM specifically, but I think this will develop going forward in the industry. And then just regular protocol updates and making sure that it's aligned. Best practice now is not necessarily best practice in the future, and it's making sure that we have this ongoing revisiting of the standards and protocols. So risk management, insurance, and professional indemnity. If one looks at this extract, I think this is largely covered by the practice note, and this will be different for each firm, but it needs to be developed in such a way that it works for the way that your particular consulting environment operates. Okay, so this brings us to the conclusion. So understanding the BIM concepts we've touched on. The practice note makes a fairly robust overview of this. I encourage you to read it. Make sure that you can access the practice notes. They are an incredibly useful platform for improving the consulting environment and service delivery and protecting members as well. Then if one looks at the structured execution plan, this is probably the definitive document when it comes to ensuring smooth BIM implementation and project progress, and it provides a clear project-wide lens on roles and responsibilities, and is a pivotal risk management resource and delivery driver. Then we move on to appropriate tools and management. So again, we've touched on this, making sure that the right software, the right management, the right checks and balances are in place to effectively ensure that the workflows and the best practice is translated into the final deliverables so that we minimize the liability risk. So that brings us to resources. As I mentioned before, that is the end of me. So I'm going to hand back to Oliver and our host at CISA, but I encourage you to, take a screenshot, take a snapshot of this, and use some of these resources to actually go and look at the standards that have been developed internationally, and just see what you can learn and how it can be implemented into your own practice. And supported by the practice notes from a local context and implementation point of view, there's a wealth of knowledge hosted internationally that really does provide a solid platform. So if you haven't started on your BIM journey yet, this is where you can find more than enough information to get you going. And as I said before, reach out to your local resellers as well, and make sure that you leverage their local context and insight into the local industry as well, to make sure that you get the most bang for your buck from a software perspective and in terms of meeting your overall deliverables. Okay, thank you very much. That's it from me. Oliver, back to you.
Mike, thank you very much. That has to be one of the most comprehensive presentations we've had to date. And so I really want to just thank you for the time and effort that you put in to providing us with such a resource-filled presentation. I'm going to start just with the chats. One or two people have just thrown a question or maybe a comment into the chat, and then we'll move across to any questions. But just to the attendees, if there are any questions and you haven't put them on the chat yet or into the questions and answers, please do so. So I'm just going to look here. So Mike, there was one question that came through. What are the BIM software platforms you would recommend for civil engineers in South Africa?
Again, I think it depends whether you're focused largely in the mining sector, whether you're in the water sector, what sort of work you do largely determines which packages. What we found over the years, whereas before there used to be sort of Swiss Army knife package, and it
Yeah.
did everything to a relatively simple level. But with the amount of specialization now, we're seeing very specific packages developing for wastewater treatment plants, water treatment plants, mining earthworks, mass bulk earthworks. I mean, from a simplistic point of view, I mean, we've seen a huge rise in terms of the Autodesk Civil 3D software, and that is largely the delivery platform that we use. I mean, within the Autodesk stable, there's InfraWorks, there's Forma, there's a raft of new software tools that actually come as part of a suite typically, so you have access to all these tools. I mean, but this doesn't discount the fact that there are tools from Bentley within their suite and a range of others. So it really comes down to looking at what you need to deliver and how you need to deliver it. So for us, I mean, the type of work that we do, we largely an Autodesk user. We do have some Bentley software, but it's more specialized around the hydraulics and stormwater
Okay.
management modeling and wastewater, etc. But yeah, no, it's not a simple go and buy this box answer, unfortunately.
Right. Yeah, thanks. I think you probably hit the nail on the head. And just to say, well, whatever software that you're presently utilizing within your company, just look and see if they don't have some sort of BIM component to it, and move it forward. I guess the big issue there is the cost associated to bringing in multiple softwares to fulfill your requirements. So there was another one by Koketsu, who said, and I think this is more of a statement, but maybe I can just open it up to you and see your comments around it. It says the CIDB should speed up the process of providing a mandate for organizations to adopt ISO SANS 19650. If it comes from legislative point of view, then a lot of organizations would have to shift with the paradigm. Any comments on that?
Yep, no, fantastic. If you have a big stick to beat them with, knock yourself out. You know, this is something we've been banging our heads against for quite some time. Is there's been a lot of commitment, a lot of workshops, and a lot of talk, but I think there's been a general reluctance, and I think some of this is driven by the lack of capacitation in the client bodies themselves to fully appreciate the benefits or the technical challenges. You know, we struggle with some of the most basic things. So I think there's a resistance to actually introducing more complexity, if you want to call it that,
Yeah,
into the market. But if one looks at case studies, I mean, if one looks at the UK, it's mandatory. Any government project is delivered to a certain level of BIM, and that's a very well defined and understood standard. And it's been the case for several years now. So it's definitely doable, but I think the South African context has other challenges that may not have been sort of as prevalent in sort of some of the early adopters globally.
yeah. Okay. All right. Thanks. Thank you for that. Here's another question by Clayton. It looks like there is a misconception in the industry that BIM is more about drafting. How best can this be dealt with so that South Africa can really benefit? I think in some ways you started the answer to that.
Yep, no, exactly, and this is, you know, a constant frustration, but particularly with smaller firms and smaller municipalities and less informed clients, is that, you know, everyone just thinks it's a 3D drawing package, but the real power actually comes from the data behind it. So an ongoing education, and I think as consultants we have a certain obligation as well to be part of that solution in providing our clients with sort of options and exposure and information around um, projects and software successes and the tools and the real benefits of BIM, and leveraging that. You know, I think we in the fortunate position of having a far closer handle on the successes and the benefits of BIM than many of the client organizations that we deal with, particularly in the civil engineering space.
Fantastic. So just related to this, and we're going to go a little bit more personal. Another question from Tumaleng. How and what was the decision goal in incorporating BIM in the company you work for? and what challenges did the company face and how was it overcome or tackled? A little bit more personal there, I think.
Yeah, so I think, as a multidisciplinary firm and working in both the public and private sector, what we found is that, particularly in the private sector, there were actually clients that, based on their international exposure, were starting to demand certain levels of BIM on their projects. So this was the initial catalyst, was to make sure that you're still relevant. As a
Yeah,
consultancy, if you're being approached by clients that have a certain demand in terms of service offering, and you say, well, actually, we'll just give you a pack of 2D drawings, and that's how we've always done it, you're very quickly going to lose market share at an exponential rate. So for us, it was really adapting to the market demands that we were seeing from clients across the spectrum. Less so in the public sector, but more so in the private sector, where I think there is a far sort of greater focus in terms of commercial acuity, in terms of getting things done better and delivered faster and more cost effectively. And I think there's a greater appreciation of what data can do, and the value of data. Data, I think, is effectively the new currency now, and we're seeing it more and more with the rise in AI and the integration of
yeah,
AI into
yeah,
BIM, and all sorts of other things. So for us as an organization, it really was this response to client demand, and also having come from, I mean, from an historical point of view, MPA Mott was born out of the purchase of Mott MacDonald, Southern Africa, when Mott MacDonald left Africa. So having worked within Mott MacDonald since 2012, 2013, we had already seen the benefits of working internationally within a UK-centric environment of the BIM implementation. So it was very clear what the trajectory was, and we were then very keen to replicate that into a more. So take those lessons learned from an international consultancy that was very, very pro BIM from sort of the early days, and then distill that and leverage the positive lessons learned into something that we could deliver more locally. And I think it also has provided, probably, I would say, more incentive to be more engaging with staff. I think for a lot of people, just regular drafting work was a bit mind numbing. But I think
yeah.
BIM has opened up a whole range of new roles and opportunities where people have been able to develop their talents. And we're constantly looking to expand skills internally, and I think this is something that the industry needs to. You will never be able to stop learning, and the reality is, given the skills shortages in South Africa, you need to have a constant flow of skills development on an ongoing basis to make sure that, if your top three BIM guys get poached tomorrow, does that sort of decimate your entire business, or do you have
Yeah.
enough resilience built into the company to survive that? So that's our approach, has been to take what we've learned from international best practice, respond to our clients' requirements, and to also use it as a mechanism for sort of enhanced staff engagement and development opportunities.
Lovely. And I guess, as you said, the fact that you were always an international company, I guess the benefits of BIM was visible through the other countries, and obviously the implementation was a bit easier. I guess if you're a local company, possibly seeing the benefits of BIM might be in you testing and trying it out and seeing what happens thereafter.
Yep.
So we've got some other questions that have come through, which actually kind of jumps on the back of those ones. There's two of them. One is, are there any recommended certifications for BIM? And another one was, in terms of upskilling current staff for BIM implementation, where should a public sector organization start, and should they become BIM modelers themselves? So maybe two slightly different. Maybe let's answer the first one with just the certifications for BIM.
So certifications for BIM, there are a very limited number of generic certifications. Most of the certifications locally are largely developed by the software vendors themselves. So
Okay.
whether it be Autodesk or Microsoft or whatever, you can do the respective courses and grades within those. But I also just want to sort of point out that having the qualification is largely meaningless unless you have the project experience.
Yeah.
You know,
Yeah.
we have fantastic sort of BIM modelers that have never been on a sort of formal course, but you know, they spent late nights watching YouTube videos and reading every piece of training material they could get their hands on, and so develop their skills. And the
Yeah.
reality is, working on a live project is the best way to learn. You know, so much of the theory just doesn't really translate until you've actually sort of used it in a
Mm.
real world environment. So
Absolutely.
you
Yeah.
can do test projects, you can sort of experiment, etc. You can sandbox it, but the bottom line is you need to pick a point and actually say, right, now we're going to deliver this little piece of work as a BIM project, and only then do you
Mm.
start appreciating the complexities. You very quickly find where the technical limitations are in terms of your own skills, etc. So this is definitely one of the easiest ways to get there. So while qualifications give you some sort of um, credibility, project experience definitely gives you the more useful skill set.
Yeah. Lovely. And I think that kind of answers the question with regards to, in terms of upskilling current staff for BIM implementation, where should a public sector organization start? And I guess it's, well, start with a BIM project and, just allow the staff to learn on the go. And I mean, as a lecturer for many years, I can appreciate that. It's the theory is one thing. It's the applying the theory into a practical situation where you really learn. And so I thank you for that.
Yeah,
Just
just
looking
on
here.
that note, I think you know,
Yeah,
one of the a mentor many years ago said to me, your worst experiences will always be your best lessons. So you sort of
exactly.
just have to take that mindset and sort of keep going.
Yeah, absolutely, absolutely. Never see anything as a failure, but merely as an opportunity to go forward and to build on it. Absolutely, I agree with that 100%. Just trying to see other things here. How do you guys get contractors involved at early stages, especially the ones who have established digital or virtual designs and construction VDC teams?
So typically what we find is that's actually more driven by the contractor. So where a contractor has a very strong virtual design team, you'll very quickly know about it because they'll be the first one to tell you. So it makes collaboration much easier from the outset, where the contractor does have a very strong digital delivery team. I mean, there are a handful of contractors locally that have really sort of shot the lights out when it comes to digital adoption, and it makes it much easier because not only do they understand the language and the pitfalls, etc., that they've been through the process multiple times and are able to translate that into their own procurement and requirements, etc., which makes it much easier from a consultant point of view to deliver the information in a fashion that works best for the way the project's actually going to be delivered.
Lovely. Thank you. Thank you. So here's another question. Considering how BIM is all about information management throughout the entire life cycle of a project, how do we make sure we don't neglect the O&M stage and not just end at construction?
Yep. So in the South African context, that's a big challenge at the moment because the reality is that there's again a small contingent of operators and owners and managers that actually fully appreciate the benefit that BIM delivers. But I think what we're seeing, and if one looks at the international trajectories, the push towards, you know, decarbonizing by 2030, 2040, 2050 actually means that facilities managers are starting to take a far greater interest in making sure that they have some sort of benefit from BIM. You know, all too often the project's handed over, you know, 20 lever arch files get buried in the basement somewhere, and that's the end of it. I think as cloud storage has become far more affordable, AI tools have developed, we're seeing a lot more O&M tools that have been built around leveraging BIM data as inputs. So I think in the next couple of years, we're definitely going to see an uptick around that. And funnily enough, there's also a push from the insurance industry and other external parties as well from a risk management point of view. So
Yeah.
say, you know, look, you know, these are your weather risks, these are your sort of building dilapidation risks, etc. How are you addressing these? And this is where BIM potentially fills some of these gaps, particularly from a climate change point of view, looking at the impact of hotter climates on air conditioning systems. Having the right
Yes.
data in place makes it much easier to remodel and reevaluate these and see what mitigation measures can be applied to de-risk a project, even an existing project.
Lovely. Lovely. Thanks. Yeah, Mike, I don't see any other questions. So I'm going to take this opportunity just to close. And so colleagues and friends of CISA, at this point, we've reached the end of today's webinar. And I'd like to take this opportunity to once again thank Mike for giving of his time and for sharing his knowledge and thoughts with us, as well as for our delegates for supporting CISA and attending our webinar. In closing, I kindly request that the delegates complete the satisfaction survey that will appear on your screen at the end of the webinar. Delegates registered with EXA may claim a 0.15 CPD point for attending this webinar as per our webinar attendance list. The webinar will also be made available on our CETV platform, which is our YouTube channel. Please note this will take a little bit of time just to do the editing, and so you can expect it probably early next week. And so again, thank you very much for your attendance. Mike, thank you for the time and for your effort. It really is appreciated. And on that note, I would like to say from CISA's perspective and CISA's side, a wonderful goodbye and enjoy the rest of your week. Thank you very much.